Lesson 8.8, Volume and Surface Area of Composite Figures. Volume of a composite figure. The volume of a composite figure can be found by separating the figure into solids whose volumes you know how to find. So if we go down to example A, it says find the volume of the composite figure. So what we're going to do is we're going to split this figure into different three-dimensional shapes that we know how to find the volume of. So I'm going to split it right here. So I have a rectangular prism, and a rectangular prism. Okay, so I'm going to go ahead and start with the top. Okay, so again, to find the volume of a rectangular prism, it's the area of the base times the height. Okay, so I've recognized that my base is a rectangle. So to find the area of a rectangle, it's base times height. So we have 12 times 6. And then times how tall is that prism? Well, I know that this whole length here is 9, but from here to here is 7, so this is 2 centimeters. So the height of my prism is 2 centimeters. Okay, then I take 12 times 6 times 2, and I get 144. All right, now I need to find the volume of my other two prisms. Okay, so again, I have volume equals the area of the base times the height. And again, I have two rectangular prisms. So then I find my base and my height. So I have 6 times 1. And then times, well, how tall is that prism? Well, it's 7 centimeters. Okay, and then we can look at this. So again, when we have parallel sides, we know that they're the same. In this figure, we have a parallel prism, so we also know that they're the same. So we could take this times 2. So now we have 6 times 1 times 7 times 2, and that's 84. Okay, just like before when we found the area of composite figures, we have to add together all of our areas. Same thing here. We have to take both of our areas and add them together. So I have 144 plus 84, and that gives me 228. Okay, so I would say the volume is 228 centimeters cubed. Again, volume is cubed because it's how many cubic units will fit inside this figure. So when we're finding the volume of a composite figure, you break it up into different prisms or pyramids that you know how to find the volume of. You find the volume of each one, and then you add them together. Okay, the next thing we're going to do is we're going to find the surface area of a composite figure. So you can also find the surface area of composite figures by finding the areas of the faces that make up the composite figure. Okay? Now, when we look at example B, it says find the surface area of the steps that are represented by the composite figure shown. When we are finding area of the composite figure, we are only finding area of the faces that we can touch. So if we were to actually have this figure in our hand, what faces could we touch? That's the areas we're finding. Or you can think of it as if we were to wrap this figure, what faces would we actually wrap? What would we need wrapping paper for? Okay? So I'm going to go ahead and I'm going to cut this up into shapes I know again. So I know I have this cube here, and then I have this rectangular prism. So I'm going to go ahead and start with the front. Now, this whole side is 3 feet. If I know that this side is 2, this parallel side is 2, so this parallel side is 2 feet. Okay? So if this whole thing is 2, or is 3, and this is 1, so that leaves this side left as 1 foot. So I go ahead and fill in different values so it's easier for me to find the areas. Okay? I'm going to start with this face right here. So I know that it's a square. To find the area of a square, I take base times height. So I have 2 times 2. Okay? And again, when we're finding these areas, do we have parallel faces? Do we have a face that's parallel? If we do, they're the exact same thing. So I do have a parallel face on the other side, so I can take that times 2. Okay? And then I'm going to move to the top. So again, I have a 2 by 2. And I have 2 of those. Okay, I have the top and the bottom. Then I move to this side over here, which is again a 2 by 2. Now, this is the one you have to be cautious on. It does have a parallel side, but you can't see the whole face, so we can't take this one times 2. Again, we're only finding area of the faces we could touch. So I have to leave that one as it is. Okay? Then I'm going to move to the smaller rectangular prism. So I'm going to start with the front here again. So I have a 1 by 1. And again, I have a parallel face to that, so I could take it times 2. Then I move to the side. I have a 2 by 1. Now again, this is where we have to be careful because we do have a parallel face to it, but we can't touch it, so we can't include this in with our area. Then I'm going to move to the top, which is another 2 by 1. And I do have a parallel side, which is the bottom, so I could take that times 2. Okay? Now I think I found all the faces except for this face right here. We do have to include this face in. Okay? So we could use our parallel edges to figure out what are our lengths and our widths. Well, if this is 2, this side's 2, so this side's 2 feet. Okay? If this was 1 centimeter, this is 1 centimeter, so this side, or 1 foot, so this would be 1 foot. So we have another 2 by 1. Okay, and then we're going to go ahead and multiply all these together. So 2 times 2 times 2 is 8. 2 times 2 times 2 is 8. 2 times 2 is 4. 1 times 1 times 2 is 2. 2 times 1 is 2. 2 times 1 times 2 is 4. And 2 times 1 is 2. Okay? Now again, I can kind of count to see, do I have all my faces? So 2, 4, 5, 6, 7, 8, 9, 10, 11. And if I look at my shape, do I have all my faces? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yes, I have them all. Once I have all my faces, now I can go ahead and add them. So I have 8 plus 8 plus 4 plus 2 plus 2 plus 4 plus 2. And that equals 30. So we would say the area of this figure is 30 feet squared. And again, area is squared because we're figuring out how many square units fit on all of these faces. Okay, again, when you're finding surface area of a composite figure, you break it down to all the faces. We find the area of all the faces. If you have a parallel face, you can take that times 2 because they're congruent. And we're only finding the area of the faces that we can actually physically touch. So again, if we were wrapping it, what faces would we wrap? If you can't touch it, then don't include that area.